Now let's look at how functions can be related to graphing. A function can be expressed as a set of pairs, just like we've seen with the curly brackets, and a function as a set of ordered pairs looks like a coordinate point, where you have like a 2 as the input and maybe 3 as your output. And there's a long list of them. So 4, 7. I'm just making something up. Comma, and then another ordered pair. These are like coordinate points that you could graph, where the first entry, the domain, is like your x, and the second value or entry is like your y or your range value. To determine if this graph is a function, we can use something called the vertical line test. So let's say I have 2 graphs. The first graph looks something like a cubic polynomial. It starts out on the bottom left, comes up, then goes down, then comes back up again, and keeps on going. Let's say the second one kind of looks like the letter C, and it curves on over to the right. And so we can use the vertical line test to check to see if this is an actual function. So this is going to be my vertical line, and I'm just going to drag this vertical line along the first graph I made. Notice that no matter where I drag it, it only ever touches the graph in one place at any given time. However, if I drag it over to my second graph, notice that it doesn't touch the graph at all, and then it bumps in one place, right here. And then, if I keep on moving it, it actually, the graph hits this vertical line in 2 places, at the top and then down here. This will continue on, and so this does not pass the vertical line test. This is not a function. So if we want to find the domain and range of a function when the graph is given, we first check to see if it passes the vertical line test. It does, so it is indeed a function. And now we're looking for the inputs. Those are where the function exists along the x-axis, and then the outputs, how far the function exists in the vertical direction. Now, there are a few different ways you can think about this. You can also make a process, a step-by-step process for yourself, especially if you find graphing to be challenging. What I would recommend you do is look at how far the function goes left to right and highlight that. I'm not looking at how high it goes. Just like if there was a light bulb up here and it was shining down on this line, and what would its shadow look like? Well, the shadow would hit this x-axis down here, and it would look something like this. The shadow would hit between 1 and 5. That's what we call the domain. Now we're going to take this light bulb idea and we're going to change it so that it's shining toward the y-axis instead. So now my light bulb is over here, and it's shining light toward the graph and seeing where the shadow will hit on the y-axis. If we look at that, the shadow will hit between 0 and 2. That means that this function has a domain from 1 to 5, and since we have closed dots on the ends, this is a domain value including 1 and including 5. And then range will be from 0 to 2. Let's look at exercise 5. The following graphs are shown. In each case, determine whether the given graph is a graph of a function or not. Then give the domain and range. The axes are marked off in 1 unit intervals. So we have this curve. It's certainly a function because it passes the vertical line test. If we have a graph of f of x, we need to figure out how it's going to represent the inputs. Now, just like before, we need to figure out where the x values exist. If I look along the x-axis, there is graph. If I were to say shine a light bulb here, it would shine down onto the x-axis between 0 and 4. If I were to shine upwards, this graph would also exist from -2 to 0. So along the x-axis, I have an interval that includes the endpoints because the graph has closed dots at the ends. So we use square brackets. And it will include -2 to 4. So my domain, the x values, the inputs, will be from -2 to 4. Now I need to look at how this represents the height. So how tall does this function get? How far down does it go? This is the vertical distance, the range. And so I'm going to change colors here. And so we're looking at how far down it goes. Well, the lowest point on this graph is at -4, and it is a closed dot. So from -4, then we go up. The function still exists. It keeps on going up, 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 and it stops at 3. So my range goes from -4 to +3, and that's also bracketed on both sides because we include the endpoints. So filling in my values, I have -2 to 4. We could also say this is open bracket, -2, 4, close bracket. That's kind of the notation that you need to get used to saying in your head for intervals. The range is open bracket, -4 to 3, close bracket. This is a function. So we can say yes, it is. And we need to find f of 4. That means my number inside the function is 4. X equals 4. My input is 4. So I'm going to find 4 on the x-axis and then see what my corresponding y value is. Well, that's at 3. So f of 4 equals 3. And then the last question is any x values for which f of x equals -4. This is saying when y, or when the output is -4, what is the x value? And we can say, oh, well, when the y value is -4, that's along this value, y equals -4. So the only point at which that happens is right here at x equals -2. At this point, we're going to stop the video, and I'm going to let you work on part B.